So let us take a look at the image signal and its down converted component to get an idea if we can somehow simplify the requirement on the image rejection, because this matching of these two paths may not be always highly accurate. Okay, and the idea is we can reduce the effect of image with the help of two techniques. One is we can implement an image reject filter which can attenuate the image. So instead of dealing with the complete image signal after attenuation, we may be only dealing with an attenuated component. And second technique is with the help of quadrature mixing, as we have seen here. With the help of these two quadrature components, their mixing products can be passed through independently in this manner, such that we add Hilbert transform in one of the paths and their summation will get rid of the image component. Now, depending on the matching of the two paths, we find that there is always some requirement of an image reject filter. And this image reject filter spec can be very tight, because in many cases this image signal can be much stronger than the desired signal. In such a scenario, even after the rejection, you'll find that the image is not so much reduced as compared to the desired signal. Now we see that if we keep on reducing the value of intermediate frequency, which is the gap between the LO and these two signal components, it turns out that the job of image reject filter becomes even tougher. Okay, because then it has to have a very high order, very sharp roll off. But what if we reduce the intermediate frequency such a way that this LO signal is lying directly on top of the desired signal? Scenarios, we have chosen FLO to be equal to FRF, because then it looks like there is no separate image signal. But what is happening is both of these signals from the positive and the negative frequencies will appear around DC, and you can see that signal from the positive frequency will appear like this, let's say. Similarly, something from the negative frequency will appear like this. So if we don't do anything and then just down convert with the help of a single LO, the signal at the baseband are going to overlap from the two frequencies, positive and negative, as a result of which we are going to get a superposition of these two components. Okay. And the superposition, or this overlap of these two components, may actually cause a loss of information, since the frequencies which are below the LO may not be have the same information as the frequency which is above the LO. Their overlap may correct the overall the information in the desired signal. Here we are talking about case of a signal which is asymmetric around And this is a common scenario whenever we talk about complex modulated signals. Now, earlier we have already seen that whenever there is an overlap as a result of the down conversion, uh, we are able to separate the signal and the image with the help of the quadrature mixing. The same technique can be applied in this case also, where signal is its own image. Okay, so what we can do is, we can, instead of doing a multiplication with a single LO, we will do quadrature mixing. Their outputs first filtered by channel select filter, and this scenario we can see that this channel select filter will be just a low pass filter. Low pass filter as channel select filter, and these outputs, I and Q, which are right now be around DC, can be digitized. As we have seen, we can add a 90-degree phase shift in the Q path and add the two signals so as to extract the signal component without losing the information. Okay. And I will just put all those operations as a part of a digital signal processing block. So now we have seen a slightly different architecture where the LO is same as the RF frequency, and here you can see one benefit in terms of digitalization is the down converted signal is around DC. So accordingly, the sampling frequency of the ADC also needs to be, or and the tracking bandwidth of the ADC needs to handle only low frequency signals, as well as the channel select filter has become a simple low pass filter. So this architecture, where there is no additional intermediate frequency, so there is only one RF frequency, LO frequency same as the RF frequency, giving rise to signal at DC, is also called as Homodyne receiver. Homodyne means we are dealing with only single frequency. It is also called as direct conversion receiver. Since the signal is its own image, so we are completely aware about the power of the image here, because it's the same as the signal power. So as a result of which, the requirement of the image rejection from this quadrature mixing architecture is substantially reduced as compared to the design where there was an intermediate frequency, because in such a scenario always there is an image signal which may have, depending on the case, much higher power compared to the desired signal. So receiver signal is its own image, which implies image power is same as signal power, block called quadrature mixer. This image rejection requirement is relaxed, and we can already see ADC and channel select filter design are also simplified. This architecture is very popular, and for rest of the course, we will just assume that we are dealing with a direct conversion receiver.